Hello, in this video I'm going to talk about geometric sequences. Specifically about the use of the formula for the nth term. The formula for the nth term of a geometric sequence is given on page 3 of your formula booklet. The formula states that un is equal to u1 multiplied by r to the power of n minus 1, where u1 is the first term and r is the common ratio. The diagram shown here is to help illustrate that formula. In this first example, we're asked to find in which year Caroline's salary will first exceed €60,000. So as her salary increases by 5% each year, we should start by identifying the multiplying factor. 100% plus 5% is 105%, which is equal to 1.05. So as stated, in her first year, she earns €48,000. Multiplying this value by 1.05, we will find her salary in the second year, €50,400. And multiplying this salary by 1.05 again, we'll get her salary in the third year, €52,920. We can see that this is a geometric sequence. And we should state the first term, 48,000, the u1, and the common ratio, 1.05 for r. Using the formula for the nth term, as given in your formula booklet, we can substitute in the values of u1 and r. To find in which year Caroline's salary exceeds 60,000, we need to find which term that is. So we form an equation by setting the nth term, un, equal to 60,000. And we use solver on the calculator to solve the equation. From the main menu, if we select equation, and then press F3 for solver, followed by F2 to delete any previous equation, and F1 to confirm the deletion. We're then ready to type in our equation. So type in 60,000 and then shift to get to the equal sign, 48,000 multiplied by bracket 1.05 close bracket to the power, and then we use x for the variable n, take away 1. Pressing execute to enter the equation. Just to note that the number next to x is not the solution to this equation, as we haven't pressed solve yet. Pressing F6 to solve the equation, we see that x, or n in our case, is 5.57. Now we can't have 5.57 terms in a sequence, so we round to 6. But Caroline's salary will first exceed €60,000 in her 6th year. In this example, we're given information about a geometric sequence, and we're asked to find the first term and the common ratio. A good idea, I think, is to draw a diagram, identifying the given information, in this case that the second term is -6, and that the fifth term is 162, and leaving spaces for all the missing terms. Consider then that the second term, negative 6, is multiplied by r to get to the third term, which is then multiplied by r again to get to the fourth term, which is then multiplied by r again to get to the fifth term. So if we write that fact as an equation, that negative 6 multiplied by r again, and again a third time, will give 162. We can then solve the equation to find r, the common ratio. We can either do this algebraically, given r equals negative 3 as shown, or we can use solver on the calculator to solve the equation. So to do that, if I press F1 for a repeat calculation, F2 to delete my previous equation, and F1 to confirm that, I can now type in the equation. And I can type in the first line. I can type in negative 6 multiplied by x multiplied by x multiplied by x shift equals 162. Press in execute to enter the equation, and then press in F6 to solve the equation. Given x, or in our case r, equals negative 3. You can type the equation in any form. Now to find the first term, we need to work backwards from the second term. And we can do that by dividing by the common ratio, r. So dividing the second term, negative 6, by the common ratio, negative 3, gives a value of 2. So the first term is 2, and the common ratio is negative 3. Another way of finding the first term and the common ratio is to use the fact that the second term is negative 6 to write an equation using the formula for the nth term as given in your formula booklet. So replacing n with 2 and un or u2 with negative 6 as shown. And then if we repeat that process, knowing that the fifth term was 162, this time replacing n with 5 and equating it equal to 162 gives us a second equation involving u1 and r. To solve this pair of simultaneous equations, we can divide the bigger equation by the smaller equation, as shown here, and then cancel down. First cancelling the u1s, and then the r's, as shown, giving negative 27 equals r cubed. Again giving r equals negative 3, as before. Then to find u1, if we substitute our value of r, negative 3, back into the first, which is the easier equation, and solving that by division again gives u1, the first term, is 2. To find the 10th term of the sequence, if we use the formula for the nth term of the sequence and replace u1 with 2, r with negative 3, and n for the 10th term with 10. Given a value of negative 39,366. And this can be verified by calculating the missing terms, as shown. In this final example, we're asked to predict, to the nearest thousand, the number of students taking the IB in a region in 5 years' time. We're told the number is currently 12,000 and it increases by 5% each year. So if we start by identifying the multiplying factor, which is 1.05. Currently there are 12,000 students taking the IB, and if we multiply this by 1.05, we'll find the number in 1 year's time, 12,600. And if we multiply this number by 1.05, we'll find the number taking the IB in this region in 2 years' time, 13,230. So this is a geometric sequence with a first term of 12,000 and a common ratio of 1.05. So to find the number in 5 years' time, we need to identify that it's the sixth term of the sequence. And if you're not sure, it's best to write them down. And then you can see in 5 years' time, it's the sixth term sequence. So again, if we use our formula for the nth term, un, as given in your formula booklet, replacing u1 first term with 12,000 and r with 1.05, the common ratio. Then if we set n is equal to 6, as shown, and perform the calculation, we will get a value of 15,315.4. So in 5 years' time, approximately 15,000 students in the region will be taking the IB.